Hey everyone, so this is a refresher in Matlab coding. This can be used in Lab 4 if you're doing the virtual option, and then also in Lab 5, everyone will need it. So this is the basic Matlab window. Here is our current directory. So anything that we are typing here in the command window, any lines of code that we use can access anything in the current directory folder. And here's our command window. These are just for really simple commands. It's going to show you the answers. If you happen to have any variables, this is where it'll show up in your workspace. And then in the command window can access those and use them and stuff like that. So workspace will be very helpful. It shows you what variables you have, what types they are, and what their values are. When you create a code file, that's either going to be new script or control N, any of those. It's going to show up like this. It's already have line numbers and stuff like that. And you can just go ahead and start coding, and works pretty easily. In this language, you do need semicolons at the end if you want no outputs. If I wanted to see x equals 5 on the screen when I run it, then I can leave it blank. Another thing that's really useful for starting a new Matlab code is to clear all your variables and clear the command window. So clear and CLC with the semicolons will do that. So now when I run this, I should see x equals 5 print out on the screen. If you want to run without saving, that's run section. If you want to run and save, that's just regular run. So I'm going to call this refresher. Now that it's named, I can run it, and it shows x equals 5 on the screen. If I don't want any output, I go ahead and suppress it with a semicolon. Nothing happened, but 5 still exists as a variable. Another cool thing about Matlab is you don't have to define your variable type. It's already set up. Since we're not on microprocessors, we are not concerned with our variable size, how many bits it takes. So we can just define a variable by name without a type. So if I did, this would normally have to be a float in Arduino or some other program languages, but this handles it just fine. And now I run, X and Y exist. You can also set up an array pretty easily. If I want the numbers 1 through 5 to be stored in my matrix or array called X, I would do 1:5. Now we can see that X is populated as an array, 1, 2, 3, 4, 5. An odd thing about Matlab is that it's 0 indexed, which means if I want to access the first position in this array in basically every other language, I would look at the 0th index, but in Matlab, I look at the first index. Here, answer is 1. So that's X at the first index. If you're declaring an array by hand, you would use square brackets. When you're indexing to get the value, that is parentheses. Cool. You could also define an array with a step value. The default is a step of 1, so 1, 2, 3, 4, 5. But if I wanted to count by if I wanted to count by 2s to 10, I can put a step here in the middle. And now I want to see X. So it's counting by 2s between 1 and 10, 10 being inclusive. So if I were to do 2 by 2s to 10, 2, 4, 6, 8, 10, something like that. So that's how we do our normal variables. In some of the starter code I'm giving you for Lab 4 and 5, we're going to use another type of variable called a structure, which is pretty much like an object or a class. If you've ever done object-oriented programming in C++ or Java, stuff like that. So for Lab 4, I'm going to be using what's called I call the maze structure, and that has member variables, X, Y, start position, start direction, and finish position, stuff like that. The supplement I included with Lab 4 shows you how to those are described, but this is how you access things. So if I have a maze that has a member variable x and I set it to a value, I want to see what maze looks like. It's a structure with two named fields. And then these named fields in themselves don't have to be integers or floats. They could be whole arrays as well. So if I were to say x is equal to 1 to 10, 10, and then it knows maze.x is a different variable than just x. So actually, I should probably be doing something more descriptive, or at least have a different name so I can keep track of which is which. There's that. And now if I take a look at maze, what it is, you can also double click anything that's in the workspace and it can show you what's inside there. So here's a field, there's a field, etc. You can also double click on a MAT file to load the data. So here's your test structure from lab 4. This one has, it's a struct made of an array. So there we go. It's the 1 by 10 struct, which means there's 10 rows of data, and each row has these named fields. And actually, each of these fields is in itself a structure because they have member variables as well. The correct explores have a left and a right. The correct optimizations have a left and a right. And then the maze has X, Y, blah, blah, blah. So that's the different types of variables. A struct, see here, indexes its fields with a dot because it's a member. An array, like I was showing you, uses parentheses. If we had a string, that can also be accessed with indices. So a string or a character are both using these single quotes. So the first index of Z is the letter A. You can also use your array functions for indices. So if I wanted to see Z at indexes 1 through 2, that would show up as A, B. And that's what you'll use for your moves list and how to index those at certain points. For example, if I wanted to say Z at 4 is equal to D. So now when we print out Z at the end here, it has all of these. Another thing that you'll really want to use in this lab is loops. So instead of using curly braces for loops in Matlab, we're going to use matching end functions. So if I wanted to do a for loop, I could say for I is equal to 1 through 10. So this is the same as an incremental for loop in C++, where we would do for int I is equal to 0, I is less than 10, I plus plus. This is the same thing here. And Matlab will do a lot of auto indenting for you as well. Comments are percentage signs. So that's how we would do a for loop. And an if statement here looks like this. Cool. So go ahead and take a guess for yourselves what this should print if you see here. So we're looping for the numbers 1 through 10. And if I is greater than 5, I want it to display I. So we should see the numbers 6 through 10. There we go, 6, 7, 8, 9, 10. Good. Cool. Another way of doing this is display. That will give you not I equals, just whatever the variable is at that loop. We could also do an fprint statement, which looks like this. This actually does use double quotes for a concatenated string. And then this is a placeholder for whatever variable we want to put in there. And then we can give it the number just as an integer, whatever number it is. It's going to convert it. This %i means integer here. So, and then we also want a new line character, just like we do a serial print ln for new line. That's what this \n means. Cool. The value of I is, and then it replaced the number, etc., etc. So fprintf statements would be pretty useful for debugging. We could also take a look at breakpoints. So this will pause your code, just like if you were in debugging mode for C++ or Python or something like that. So as soon as we put a breakpoint in, if it reaches this line, it's going to pause the program here, and we can see that our current value is 6 because that's the first time we encountered this line of code. And we can also see the full value of x where we couldn't before. Cool. And then you can erase the breakpoint at any time and continue. Cool. Another thing we'll use, but you don't necessarily have to build yourself, is a function. So just like we built our own functions in Arduino, like turn and drive and stuff like that, we can build a function here in Matlab. So we have this keyword function, and then we'll say that our outputs equal the function name of our inputs. And we have it matching n key. But one thing that's different about Matlab is the functions have to, the first one has to have the same name as our code, and that basically acts as our main. So if you've ever had a programming language where it needed a main, and it can't let me see, okay, cool. And this is where we can, now that we have that set up, we can create another function. Sum is equal to add a and b. And then we can say sum is equal to a plus b. And then if we have our output name here, as long as we define it somewhere in here, we don't need a return statement. It's just going to take that. And there we go, a equals 5, b equals 10. And then we have x is equal to add ab, display x. So if we put a breakpoint in here, and I go ahead and save it. In this case, we don't actually have any outputs or inputs for this function, so we can just look at it like that. And now if I run this, I can do it step by step, or I can continue to the next time I hit the breakpoint. But we don't have a second breakpoint in here, so I'm just going to step through. So it defines A, it shows up in our workspace. It defines B, same thing. And here we come to a function where we can step in. And I need to hide the zoom controls to get at my button. Okay, we're going to step in, and that takes us inside the function. And I didn't have any breakpoints there, so it just went ahead to the end. And now we can see that sum is defined as a plus b. But as soon as we leave this, sum is going to be destroyed, and the output is going to be stored in x. So when we step through here, there's no more sum, but now x is defined. Displays it and continue. Cool. So that's how you would use functions. You can also call any function that's in your same directory. So if I were to come in here, if I want this function to load our variable, this mat file, that's the code for loading the mat file. And then if I want to say draw the maze tests1.maze. And then this would actually have to be I save it here in this folder. There it goes, it showed up. Now I can access any of these functions. And if I press run, it called the function draw maze, and that's where it drew. So there is an overview of variables, variable types, syntax for breakpoints and print statements, and some functions. We'll be going over into some other types of MATLAB objects as a refresher course when we get to Lab 5. But there's that for now.